provides single and multi-regional storage in the Google Cloud Storage. Then there is Google Cloud Bigtable. Bigtable is a columnar database and provides you a scalable offering across regions. Then there is Google Cloud SQL, which is nothing but managed MySQL or PostgreSQL, and you can use it based on if you need a relational database or not. Then there is Google Cloud Spanner, which is slightly different than PostgreSQL or MySQL in the sense that it's a SQL compliant transaction promise database, and we'll talk about that in detail in next few slides. But it distributes across the globe, and it provides something very unique that other relational databases typically don't provide. Then there is Google BigQuery, which is used for querying data which is big enough, spanning across multiple like buckets in a way, right? Then on the big data side, there is BigQuery, which I think I have mentioned earlier. There is Cloud Data Flow, which is basically for orchestrating, streaming kind of data flowing through a workflow. Dataprog, I'm not sure. Data Lab also, I'm not sure. Cloud Iot Core is an IoT offering from Google. I think it is still in beta or private beta, I'm not sure, but so it is not publicly or production use ready yet. But it basically provides you a device management, device security, and device communication for your devices, basically IoT devices, in a scalable manner. Then there is Cloud PubSub, which is nothing but a PubSub-based queue, highly scalable, which you can use for communication in an asynchronous manner across your systems. And then there is Hadoop. So basically, you don't have to spend time setting up Hadoop by yourself, and you can just use a managed Hadoop for yourself, right? On the machine learning side, there is Cloud ML Engine, which is basically TensorFlow as a service. So you can define your models. You can use those models to train the data, and then optimize your models and data both over a period of time to use those models for real production users, right? Then the vision, speech, natural language, and prediction and translation APIs are specialized services coming from machine learning. So vision basically gives you, you can give it a photo, and it's going to tell you whatever it can determine from that photo. And for this, I have actually a demo, fortunately, because I didn't have to spend too much time building the demo. It's live available on the Google website, so we'll try that out. We'll see how intelligent it behaves, and we'll see, based on different photos, how different predictions and outputs it gives to us, right? Speech API gives you speech-to-text capability, pretty much what probably being used in Google Home. So you talk something, and then you get the text format, and then you can use that to use for further actions on your data. Natural language is a way to determine, write English-like language and figure out what action the user is being trying to say, right? Prediction API, I believe, is also used in the Vision API. So it predicts based on data, what could be the next thing or next action sort of out of that data, right? And translation API is nothing but your Google Translate as an API. So you can give it a text in one language and get the text in another language back. There is also Video Intelligence API, which basically you give it a video and it's going to give you intelligence out of video, the way it does with photos, and then you can use that intelligence to do certain things, right? And then there is something called as AutoML, which was announced day before yesterday or last week on Google's blog. AutoML is still not available for anybody to access. It's only available in a private alpha access. So only a few people from Google and maybe some early customers are getting access to that. But what AutoML promises to be is that instead of you learning all the machine learning things, instead of you learning all the models and optimizing all those things, you get a lot of things ready-made. And all you do is take your data and choose one of the models which aligns with the data that you're providing, and then train that model, and you're ready to go, right? So you don't need to be an ML expert, but you can still use Google AutoML, not being a very super expert in ML, right? And I think the first part of AutoML they are launching is the Vision ML, which again is not available yet, but it'll be available soon. So that's a very high level overview of a lot of Google offerings, right? But other than this, there are some more offerings, and these are again, I would say, useful in a lot of context, but I won't go over in a lot of detail in them, right? For example, in case of networking, it provides all the standard stuff like DNS, CDN, so content delivery networks, load balancing at multiple levels, like application level versus network level, SSL based or HTTP based or whatever, right? You can also have VPCs to separate your applications into different logically isolated zones, right? and the cloud VPN so that you can connect VPN to VPN point-to-point connectivity kind of thing, right? On the operations or admin side of things, there is Stackdriver, which provides a bunch of logging, monitoring, and error reporting capabilities. And you can pretty much plug that into any of the other offerings. For example, in Kubernetes Engine, I can say enable Stackdriver logging, and I get all my log data into Stackdriver, and then I get the pre-built dashboards and UI and a lot of other built-in features of Stackdriver, right? The same goes with Google App Engine as well as Compute Engine. I can say enable Stackdriver logging, and I get a pre-ready-made Stackdriver deployed for me. And I can say send all my logs from applications to this endpoint, and everything else is taken care of for me, right? Again, there is a, I would say, there is a decision that people have to make whether they want to use something off the shelf, or for example, a lot of people use Elasticsearch, a lot of people use Splunk, a lot of people use Sumo Logic, log entries, and there are a bunch of other offerings around log management, right? Same goes with monitoring. Not a lot of people, or not some people want to use Stackdriver logging. They might say, hey, I already have Prometheus, I have Zabbix, I have Grafana, I don't know what, right? There are a bunch of other tools that you can use. On the dev tools, I think most of the offerings which are very specific, for example, Google App Engine, they provide a SDK to your developer environment, like Eclipse or IntelliJ plugins. They provide something called as Cloud Shell, and I don't know if anybody of you have used, but I really love Cloud Shell. So it's like my shell, but it's on cloud. So it doesn't matter which machine I'm logging in from, and I can simply log into my Cloud Shell, and things are available to me as they would be typically, right? And then there's data transfer. I don't know, some of you might have seen last to last reInvent, there was introduction of offering. So I think Werner Vogel was presenting the offering, and then the truck came on the stage actually. So the truck had a big container, and that had a huge appliance. So for people who are dealing with like petabyte or exabyte of data, if you transfer it over internet, it probably will take you like 100 years to transfer that data, and probably billions of dollars, right? With the amount of money you pay for network transfer traffic, right? So what they do is they basically come into your infrastructure or data center, you plug that in, and you transfer data at basically the hard disk speed, and then you ask them to upload to cloud, right? And there are two different appliances. One is called Snowmobile, which is probably about this big, like that cabinet, and then there is Snow Truck. I don't know, it's not called Snow Truck, it's called something else, but it's basically a truck. So Google also has a similar offering wherein you can ask them to bring their appliance to your data center and transfer data at scale. So you don't have to think about how do I transfer so much data without paying too much about it, right? So that is a very quick and a very fast overview of things, right? And feel free to stop me anywhere if you have any questions. I sometimes tend to go too fast without breaks. So, all right.
So AWS is Snowball, I think.
Yes, Snowball. That's correct. That's correct. Cool. So let's talk about Google App Engine, right? Google Compute Engine. So Google Compute Engine is the most flexible and free environment, right? I give you a virtual machine. You decide what to do with that. Whether to run X number of applications at X load or not, right? And there is complete flexibility and freedom around that, right? You can get either one CPU or 96 vCPUs. You can get up to 624 GB of RAM on a single machine. So the variation is huge, right? From half a GB RAM to 624 GB of RAM. So it depends again what kind of workload you have, what kind of things you're doing. Are you doing graphics processing, or are you simply running like e-commerce application, those kind of things, right? And the best part is you can customize. So for example, the current setup might be like there is a 4 GB machine, there is an 8 GB machine, right? But you say, hey, I want like a 7 GB RAM, right? I like odd numbers maybe. So I just choose a machine with 7 GB RAM, and I pay only for that much GB of RAM basically for that machine, right? So there's a lot of flexibility around that. I think the billing is per second, which I think is now the case in AWS as well, right? I think they also announced right after Google announced last month.
That is for only Linux instance, it's not for Windows.
It's not for containers?
Not for Windows.
Oh, okay.
Only for Linux it is person.
Interesting. So Windows they charge still by hour? Okay. That may be Microsoft playing, behind their back. So, anyways. So you can choose hard disk or SSDs basically, and you can attach up to 64 terabytes of persistent disk on your machines. And again, the choice is really what kind of applications you're running. Do you want just like 10 GB of disk attached, or do you want 64 terabytes of QB attached, right? And all of these operations you can do using CLI. So Google Cloud provides like a G-Cloud CLI, and you can do most of the operations using G-Cloud CLI. You can do the same using API or the UI console that they have, right? Now, there is one unique feature that Google Cloud has, and I don't know how many of you noticed the recent Spectre and the meltdown viruses, right? And as of today, Google has already migrated all of them servers into the new world, right? They don't have any vulnerabilities anymore. So as soon as the Spectre was announced in September by Intel, Google was the first to start migrating their machines, and they use live migration technology for that. And there is a nice blog on the Google blog you should go and check out. Why they were the first one to really migrate out of the vulnerabilities so fast, right? So what live migration allows you to do is, even if you're running a machine, it allows you to migrate that machine to a newer version or a newer patch by affecting the performance very minorly, right? So let's say if you're running at 100% load, just an example, and it will probably degrade the performance for up to like 85 or 90%, and it will still live migrate the machine. There are of course users and customers who want absolutely no compromise with performance, right? In that case, of course, you'll have to stop the machine, do your upgrade, and then bring up the machine, which again can be easily done if you have in a group. Like let's say I have a pool of 10 machines which are actually serving my production traffic. I take out one machine, upgrade it, patch it, put it back into the pool, and I'm good, right? So like this I repeat for all machines one at a time, correct? So those kind of capabilities are there, and there's a lot of detail to what and how live migration works, and I believe they have a paper also published. You should go definitely check that out, and that's a very interesting capability of Google Cloud Platform. Now, next comes Google App Engine. So Google App Engine is something I myself heard in 2009 when there was a Google Dev Days conference here in Pune, and I was fascinated by Google App Engine that time. All I had to do was basically write my core business logic in Java and say, push or some similar command, and it deploys into Google App Engine, and it takes care of everything, deploying, managing, scaling, no matter what my user traffic is, no matter what is happening, right? Now, that time it was of course pretty nascent, and then with the evolution of PaaS, platform as a service, things got much more mature. And as of today, they have two different offerings. There is something called as Google App Engine Standard, which is very much similar to the original offering, and then there is something called as Google App Engine Flexible, which is a little more flexible. It gives a little more, like levers to do things, and we'll talk about that. So standard is nothing but it's a sandbox environment, meaning you give it a piece of code, it's going to run it in a sandbox container, and you don't know where it is running. But the good part is Google is going to promise you extremely high scalability. So for example, if you're a kind of user who is going to expect sudden spikes in traffic, right? For example, let's assume, for example, shopping websites, right? Like if I announce certain offer of 20 or 30% discount, I expect the traffic to go like completely out of the bounds, right? Without me knowing how much people are going to buy, right? For that kind of sudden spike, Google App Engine is a perfect candidate. Because they are handling it at container level and they are managing it themselves, you really don't have to worry about the scaling. But the kind of downside or limitation is that you can't access anything outside of the container by yourself. If you have to access anything outside of Google App Engine, you have to go through a certain proxy, because there is some limitation or some room for you playing with the network or whatever, right? So any service that you have to access from Google or from outside, you have to go through certain proxies of Google, and only those services are accessible within that sandbox environment, right? But the cost is very low. For example, I think up to 1 million requests per month are free. So literally, if you're, for example, a music album seller, right? And a music album, when it launches, it probably sells like bananas for first 1 month, and then nobody buys it for next 12 months, right? Perfect candidate for Google App Engine. Set up my website of that album in Google App Engine. I won't pay anything for the 9 or 10 months that nobody buys albums. And if I launch a new album, it goes up, I pay only for that spike, and that's it, I'm done, right? So very good for any company who is looking to start cheap, and then they can afford to pay as they go, right? In fact, a lot of startups that started around that time, like 2011, 12, 13, they actually opted for Google App Engine for this very promise that there is no cost to start. There is only cost to grow, basically. And because it's a sandboxed environment, the runtimes are limited. Python 2.7, Java 8, Java 7, PHP 5.5, and Golang 1.8 and 1.6. I don't know whether they don't support 1.7, but this is again off their documentation page.
So how is it different from the Google Firebase?
Firebase is more of a what I would call backend as a service. So what Firebase does is Google App Engine only gives you a sandbox environment, but you still have to design your schema. You still have to write your application code, right? When I say application code, the backend code I mean, right? And then write the front end code, right? Firebase goes one step ahead. What Firebase does is, let's say I'm writing a mobile app, and I don't really care about how the backend works. I'm not a backend developer. I really know my front end and user experience really well, right? So I can define schema on the fly. So I only say define an entity called user, right? And Firebase by itself creates all the API endpoints. Create, read, update, delete, all the CRUD operations API endpoints by itself. So literally, you don't have to write any backend code, so to speak of, right? And it also optimizes your schema and data and a lot of other backend things over a period of time. So Firebase is extremely good for developers who don't want to deal with backend code, and backend is more or less like 90% taken care by Firebase. All you do is define some basic stuff, and Firebase defines the application code for you, sort of.
Like the Firebase integrates with the cloud, like for front-end services. If we try to integrate both the Firebase and Google App Engine,
you could do that. So for example, you can say for all the basic operations, I can use Firebase, and for anything that is advanced, I can probably deploy a container in Google App Engine, right? And you can combine the two in your front end. And also understand that with Google Firebase, your front end is going to be very heavy. All of your logic is going to be written in your front end, whether it is Angular for web or native Android or native iOS client. And I think a lot of I know one e-commerce shop here in Pune which actually uses Firebase for all of their backend, and front end is very heavy with native Android or mobile apps basically. But yeah, it's a completely different offering. But good that you brought up the point.
But by using Firebase, we can't use the used database because it shows some hanging type of stuff.
Correct.
Because it's stored in JSON format, the whole data.
Document data.
Yeah,
right,
document.
Right. So I think there is a fundamental trade-off with what you choose, right? I could still start with Firebase because I don't know how much my app will get adopted, right? And let's say I realize, my app has really good potential, and let's say I reach 10,000 users. And now I have started seeing that latency. People are experiencing slowness, right? I'll probably migrate over to, at least the data part, I'll migrate over to, let's say, something more mature. And then I can, scale based on that, right? I think that's the beauty of the cloud technology, that you can start even as an individual developer really almost cheap or almost free, right? And if you see potential in your business or in your app, in whatever, right? You can then decide, okay, let's now migrate to something paid because I'm getting money, right? So that's the beauty. So let's talk about Google App Engine Flexible. And I'm sorry I don't have too many demos. I wish I had, because I was given a really short notice, but hopefully next time I can have more demos. So Google App Engine Flexible is basically Google App Engine at its core, but it gives you more access in the sense everything is deployed as a container. So you give it a container, and it deploys onto virtual machines. Now you actually get to access the virtual machines. So you can access it into the virtual machine, you can install certain packages if you want, and you can customize your virtual machine as you want. But the only challenge is, this is not great for any load which is going to suddenly go spike, right? If you know that, okay, today I'm expecting 100 users, but maybe Christmas sale I'm going to expect like 10,000 users, and maybe not more than 10,000, right? Then I can still use this offering, where I very, very clearly know how my spike looks like. So I can prepare beforehand and make 3 machines to 10, and then kind of meet the scale, right? Now it provides 2 different distinct mechanisms to deploy, right? So if your code is written in any one of Python, Java, Node.js, Go, Ruby, or PHP and .NET, it gives you a runtime. So meaning you just give it a piece of code, it will wrap that into a container and deploy that container into actual machine, right? But if you're writing in a language which is not any of those, you give it a Docker image basically, and then you still deploy on one of those virtual machines and run there, right? So it is still like App Engine in terms of developer experience, but in terms of scaling it has a different behavior, and in terms of customizations at VM level it has a different behavior, right, as compared to the standard Google App Engine. And the VMs are restarted, by the way, every week to apply patches and update your virtual machines basically. Okay, so let's talk about Google Cloud Functions.
So we are using here VMs. So like when we are installing VM in our local machine, we have the option to revert back to a original snapshot. So does Google also provide the same option, that if we want to revert a snapshot to a original one, so can we?
Yeah, so typically what companies do is that they create their base machine, right? And then apply certain patches, right? And let's call it version 1, for example, right? Now I'm running that in production for let's say 10 days, right? Tomorrow, let's say a new patch comes from a vendor, whatever software I'm using. I create a version 2 snapshot first, and then I create instances out of it, right? But then I realize when I'm running these instances, my application is running very, very slow for whatever reason, right? So I can always go back to version 1 from the snapshot that I had stored. So it gives you the capabilities to store that images and do all that stuff, but the actual work has to be still done by you, right? Google won't do it for you because Google won't know what you want. Like you might want snapshots and versioning, right? And then maybe I don't want it. Maybe my application is not requiring that kind of backward compatibility, right? So it depends on the user. So Google Cloud Functions is a function as a service from Google. You only pay for every function execution. It is still in beta, by the way, and it supports HTTP as a trigger, messaging as a trigger, and cloud storage, meaning if you drop a file into a bucket, it supports that as a trigger. And direct trigger is used for testing. Like on my CLI, I can say, can you test this function, right? Can you execute this function? Now, in my personal opinion, this is one of the offerings which has a lot more potential in terms of what Google could do, but it is not as the potential hasn't been realized. If you look at equivalent offerings from Google, Lambda from AWS or Azure Functions, they're a lot more mature. They provide a lot more things to do. For example, the only language you can run here is Node.js, not even Go, not Python, not Java, nothing. So you're really limited to Node.js. That's pretty much about Google Cloud Functions. And I have told this to Google Engineer multiple times. We need to do something about this. Like, this is.
These cloud functions also have some free bandwidth quota, like the one you said about Google App Engine Standard.
I think I don't recall the exact number, but there is some like free limit. Like initial 120 minutes of execution or something are free per day, and then beyond that, if you go, you're gonna cost money. But I don't remember. You should go and check out the offering page.
And Google also gives free credits at the initial.
Correct. So if you sign up with a new username and give your credit card, it won't charge you. Don't worry about that. It will give you $300 of credit, which you can use to experiment yourself with Google Cloud.
I had a question regarding Google Firebase.
Sure.
There is something called Google Firebase Cloud Functions, so which integrates with Firebase. So how is this offering different from that?
I think it is pretty much the same. Although I had technically not used that specific offering, but it is actually just Google Cloud Functions in Firebase basically. Cool. So Kubernetes, kind of my favorite topic because that's what I do for a living. So Google's Kubernetes engine is a fully managed Kubernetes platform, which is HIPAA compliant. I don't know, some of you may know, may not know, but for those of you who don't know, HIPAA is a compliance standard from the body of, I think, health related institutes. They certify that your cloud is compliant to this particular compliance standard if you meet certain standards. For example, when it comes to healthcare data, there's a lot of privacy concerns. There's a lot of kind of somebody profiling you concern. Like if I'm sick and if a doctor knows and somebody else knows, they can target certain medicines and those kind of things, right? So HIPAA is a compliance which kind of tries to avoid that kind of thing. So it is HIPAA compliant. And PCI compliance is basically for financial industry, meaning your machines are secure enough that they can handle PCI compliant transactions like credit card transactions, bank transactions, right? So it's a fully compliant to both of those standards. Typically, Kubernetes engine is more or less on the latest version of Kubernetes. Like right now, it is 1.9, the Kubernetes version, and I think even the offering is 1.9. So it's pretty fast to adopt the latest version of Kubernetes. The master side of Kubernetes is invisible to you. So again, to just give a context, right? So Kubernetes has a concept of master, which has X number of components, and then there are nodes where you actually deploy your workload, right? In a typical scenario, if you are deploying Kubernetes by yourself, you will manage both. But in this case, the master is completely managed by Kubernetes. It is highly available, it is redundant and replicable, and you only focus on the workload side of things. But you get complete access on the VMs, on the workload side of things, meaning you can actually go to one of those machines and do certain things if you want to do. You can choose a custom base image. Like if I don't want to play in vanilla Linux, Ubuntu 16.04, I can add additional things on top of that. And typically you can use preemptible VMs. Now what are preemptible VMs, right? It is like spot instances from AWS. In the sense, I can say, I'm going to use this machine, which is like cheaper by, let's say, 80% as compared to a normal machine. But Google has authority to kill that machine anytime if they want. They'll give me like 2 minutes notice or 3 minutes notice, and they'll take that away, the machine away, right? So what a lot of people do is, let's say I have 100 machines that I need to deploy in my production for any given workload, right? What I'll typically do is, let's say, I'll put all the critical workload on, let's say, my 50 machines which are on demand, meaning Google can't take them away if they want to. And then other 50 machines, I'll use preemptible VMs. But I'll make my applications very redundant. Like I'll always deploy 3 copies of my application. One on a preemptible VM, another on a preemptible VM, and maybe one on stable VM, right? So even if Google takes away the 2 instances at 2 minutes notice, I have enough time to move my instances from, or move my applications from those machines into other machine, and then kind of scale out, right? So you can mix and match the preemptible VMs and the normal VMs into a pool, and then use that as a Kubernetes engine, basically. But of course, you're still dealing with container as your primary unit of deployment and building applications here. You're not dealing with VMs. I'll give you a Docker image to the Kubernetes, and it's going to schedule on one of those machines, right? And talking about Kubernetes can be a huge topic. I can take next 3 hours, but I won't do that. Maybe some other occasion on that. Cool. So that's Kubernetes engine.
So,
yep.
How is Docker and Kubernetes related to each other?
They are related, but they are kind of rivals. So Docker is the runtime, meaning you say, hey, this is my application, or this is my base OS, Ubuntu XYZ, but also install XYZ libraries, right? And then install the application server, and then throw the jar file or whatever application runtime at that, and run the application at this with this command at this port, right? This is your declaration of a Docker file. This makes a container, correct? Now, typically we use Docker as a container, right? So this is your package, container. Now you give this to Kubernetes. Kubernetes is going to decide, I have 100 machines. Now where do I run this first, right? Secondly, after I have started running it, how do I keep checking it is up and running, right? If it goes down, I'll bring it up. If that machine goes down, I will make sure I move that application from that machine to some other machine which is working. I'll also attach storage to it. I'll also attach networking to it. So there's a lot of pieces which can be broadly called orchestration, which is what Kubernetes does. Whereas Docker or the container is only the runtime.
So Docker Swarm.
Docker Swarm is kind of similar offering at different levels of maturity, I would say. Mesos is another orchestrator like Kubernetes. There is an orchestrator called Triton from Giant, which is now acquired by Samsung. But so there are a bunch of orchestrators, but Kubernetes is kind of the dominant one as of today. And Docker is one of the runtimes. So if you go to OCI, you can build similar image which Kubernetes can still run, but it is not Docker container. It's an OCI container. It's an open source, container specification basically.
So can it integrate with third-party APIs? Like if I want to integrate the Keon API, Unix-based Keon APIs for encrypting my container data, can that be done?
Which OCI or Docker or which one?
With Kubernetes.
Yeah, in Kubernetes you can run technically any application. What you do inside the application is up to you. Or did I answer your question?
Can we integrate the third-party APIs?
Oh yeah, totally. So you can extend the Kubernetes API itself on its own. There is something called as custom resource definitions. So Kubernetes provides X number of objects which are built in. You can define your own object called, let's say, software engineer. It can have certain behaviors. And then Kubernetes will expose APIs of that directly. But you can also integrate with any other API of the world, doesn't matter. Then there is container registry, which is nothing but Docker registry with additional bells and whistles. Like you can search by name, you can search by tags, you have notifications, you have the vulnerability scan built into it, and it's a mirror of Docker Hub, meaning you don't have to go every time to Docker Hub. There is a copy of that kept in the Google Cloud itself, so your fetches or pulls are very fast, right? So that's about container registry. Nothing fancy here, it's all simple stuff, so I won't go over too much detail on it. Then there is Google Container Builder, which is like a CI engine, continuous integration engine, if you want to call it that way, where you can define X number of steps and then build an image out of it, and you can push that to the container registry, right? And again, notifications, audit, logging, all built into it, right? Now let's talk about container optimized OS, right? Before we move away from the container topic, sort of, right? Now, why do you want to use container optimized OS, right? Why can't I use normal Ubuntu VM or CentOS 7 VM, right? Typically, if you look at Ubuntu or a CentOS VM, first of all, it's big. It's like 700 MB of size, right? I want my VMs to be really lightweight. That is the first thing. Secondly, in my out-of-the-box VM in CentOS or Ubuntu, there might be a lot of settings that might have been done which I don't need, or which might leave some things open for attackers to attack, right? So container optimized OS is an OS which is very, very minimal, meaning it only installs what is required to run a container on it, and do some basic network and storage communication, right? That's all. So first of all, it is lightweight, but second, it is very, very secure. So your attack surface is now much smaller as compared to a normal VM. So Google have their own containerized OS. There is a container OS from Ubuntu, there is a container OS from Rancher, there is a container OS from a number of people. But ideally, you should use a container optimized OS instead of using a normal OS. Alright, so a little bit moving away from the standard container topic. So we talked about Google Cloud Spanner, right? Typically, we have been led to believe and we have thought that a relational database can only scale within certain limits and within certain geography, right? I can't have my Oracle database or MySQL database where master is in one data center, for example, India, and the slave is in another data center, which is called Europe, right? That won't work because latency will be too high, there will be other issues, right? And Google tried to solve this problem by using something called as Cloud Spanner. Now what it did is, it's a SQL compliant database. It supports transactions, but it can be globally distributed, meaning you can have it spread across all over the world. And Google uses some really novel engineering techniques behind your background to optimize and to make sure that it is still CAP compliant. The consistency, atomicity, and I don't recall what the P is called, but CAP theorem basically, right? And there is a very nice paper which talks about how Spanner and CAP kind of work together. You should go check it out. Cool. All right, now comes the fun part. So now we're going to talk about Cloud Vision API, right? What Cloud Vision API does is gives you a bunch of capabilities to look at your image and find the data about it. I won't talk. Let's just demo it. So this is the Cloud Vision API page, but if you scroll down here, you have this nice area where you can actually drop images and it'll analyze it for you. So what I did is I found a few images, and let's go one by one, right? Like images. Let's first look at images maybe and then talk about that. So let's first look at images very quickly, right? This is a logo, serverless logo. We'll see how Google analyzes that. This is a photo of Eiffel Tower, and we'll see how Google analyzes that. Another view of Google Eiffel Tower and how it looks. This is a photo from Mahabaleshwar, one of the Western Ghat hill stations and the hills. I want to really see how Google analyzes that, right? Is Google intelligent enough to also identify the place, whether it's in India or something like that, right? I'm sure it will identify that those are hills and some sky, but I want to see whether it is really intelligent enough that they map it with their Google Maps data and somehow find out that it's a location in Maharashtra. And this is Kubernetes logo. I have analyzed this today morning, and it actually tells you that it's a Kubernetes logo very clearly. And this is the Rome's Colosseum. So we'll see whether again Google tells us more than what we know, right? So let's start the fun. I'm sorry, I'm not very comfortable with Windows nowadays. It's been long, so I haven't used the Windows machine. Come on. I have to extract it. So let's start with the service logo, right? Alright. It has identified the color composition fairly well. Like right? How much text, how much font, whatever. From the web, it somehow figured out it is related to Las Vegas. I don't know why, but it also figures out serverless computing, which is pretty intelligent actually, right? But I'm still curious why it is Las Vegas. Maybe Las Vegas has a lot of red and black colors. I don't know. I'm just throwing. It also relates AWS Lambda. That's very interesting, right? These two are pretty accurate, serverless computing and serverless framework. So although the machine is actually very intelligent, it is not as intelligent as us, as of today at least. There is Python, AWS, bunch of other things, right?
Is it ranking at the left hand side?
So I think, yeah. Ranking meaning, I don't know.
Yeah, the 1.5 something like that.
It just provides a score.
Score or ranking.
Yeah, some score. I don't think it's a percentage, but if you go to labels, it gives you like with so much percentage accuracy, I can tell you. Like 97% I'm confident there is a red color in here. Right. That's pretty interesting. What are the other things? There is GitHub, there is cloud computing. So that's not bad actually, right? Properties, dominant colors, crop hence. This image is safe for searching, meaning there is no plus 18 stuff here, so that's cool. And this is the JSON. So you can actually use this JSON and build a small app to tell somebody, what are you looking at, right? Some of you might have seen there was an ad from Google, I think last month, like a tourist goes to Italy and there's some stuff written in Italian. He just points at mobile at it and he looks at it in English. So that kind of stuff, right? So that's that. Alright, let's try another image, right? The Eiffel Tower. It actually finds stuff pretty. Now, if you look at the top labels, right, they're different. Meaning it also found out landmarks. So it added a landmark as a section, right? Labels, of course, it's landmark, it's tower, it's a sky, blah blah blah. Sky because a bunch of a major portion of my image actually has a sky, right? Logos, Eiffel Tower with 30% accuracy. Yeah. I think those are probably like some indication of the number of hits on that entity. So the number, most likely again. This could be the street in Paris, Sacré. Is that what it is? I don't know. There is Champs Mars, which is another street probably.
Actually, they are the place nearby Notre Dame, and so yeah, that's why.
Sure. Sure. I mean, yeah, all the places are nearby. Why Chrysler building? Nothing to do with Chrysler, right? Is there a car with Chrysler logo in there? Cool. So, document, properties, safe search, all cool. So that's the Eiffel Tower. Let's try another version of Eiffel Tower. So that is intelligent enough to actually understand that, right? So this is all built using the machine learning that Google has. And this is a pre-built offering, right? So you don't have to do it. But you can build similar offerings if you understand ML really well, using all the Google's offerings, of course. So again, it determined landmark, which was actually pretty intelligent because I have a very different view, right? I'm taking from the bottom. There's only sky. There's not much else to find out. It's a Eiffel Tower. YouTube. Why YouTube? Why music? Dance. Oh, maybe because of the lights. Blinking lights, right? Like bright lights. Definitely dance. BQ, Brainly, whatever. Throwback Thursday. Cool. So that's cool. What else? Kubernetes is very standard. It's going to tell you it's Kubernetes logo basically. Like if you go to web, Kubernetes is the most dominant result. But this is not a very interesting one, so let's check that. Let's see this one. And I think we have the mountains also, right? Western Ghat Mountains. This I'm pretty sure it's going to identify its landmark. Yeah. So it said it's first in amphitheater, second in Colosseum. I mean, later on somewhere Colosseum. But the general concept is applied more than the specific Colosseum, right? And pretty good, like if you look at the top 10 results, they're 80+% accuracy. And all of them are relevant, right? Nothing is irrelevant. Trevi Fountain. No. Trevi Fountain is far away from here. That's more than Colosseum. Maybe Trevis Fountain is the more photographed entity on the web than Colosseum. and it is in the same region, and that's why Travis Mountain is higher. Because Travis Mountain is really like a couple of miles away from here. Okay, that's great. Let's go to the Western Ghats. Yeah, I'm really curious what it helps. Oh, Mahabaleshwar, 92% accuracy. That's not too bad, guys, right? I mean, you could take picture from any different angle. It still has all the intelligence to actually find out it's Mahabaleshwar. So it can actually identify where am I. Like if it has all the photos of me, it really knows where I have been, right? That's cool. And this region is what it has identified with this map area, right? So Rich, Sky Mountain Station, Highland. Cool. What is Jawahar Dust? Does anybody know? Is that something around Mahabaleshwar? Let's
Click on it.
Sir, right. Click on it.
Yeah. Right click? Yeah, sure. That is something else. Yeah, I don't know. Okay, so there is some mismatch in the web entities. Maybe enough people don't upload Mahabaleshwar's photo on web or whatever. Like I don't know.
So how did we identify it as Mahabaleshwar? Because Mahabaleshwar is the fourth choice. So in landmarks, how did it get Mahabaleshwar?
So this region here, this green marked region, is mapping exactly with the Google Maps entity here. There was a blog from somebody last week about how Google Maps has evolved over the last 10 years versus how Apple Maps has evolved. So whatever images Google Map took 10 years ago, they're still analyzing it. And now their accuracy is so high, they can tell you this is the building, on the front side which is the shop, on back side which is the shop, on this side which is the shop, on which floor what shop exists. So their analysis has been evolving over a period of time. And of course images they have been taking forever. But no wonder they can actually tell.
Apple doesn't use their own map.
I think the problem is not the mapping. Like, of course, Apple don't use their own cars and satellites as much as Google does. But the second part of it is actually analyzing that data, right? Like in US now, it tells you if you go in a mall on which floor, which shop is there. It actually points out this is the location you should go on.
In India, malls.
Yeah. Cool. So that was nice demo, I guess. So that's the vision idea. Now this is an offering which was launched day before yesterday called Iot Core. You can train custom models, and most of the models are pre-built, or you can choose like standard model. I have applied for early access because I'm GD. I hopefully will get access to it and play around with it before it comes to public, but let's see. And this is very promising to me at least. I'm not much of a ML guy, to be fair and frank, but I want to try something out to get into it, sort of. So that's pretty much the presentation I had, but open to questions, whatever other thing you want to discuss.
Tell something more about the last one.
Frankly, I don't know enough. I mean, Google themselves are disclosed so less. Like if you go to their web page, the offering page, there's hardly anything. It basically means, or it promises that you can build ML models without knowing ML too well. Like probably, I don't know anything of ML, right, but I could probably build like.
You don't need to know the algorithms, like which maybe regression or anything other.
Right.
Makes sense.
So that's what it is, but again, not sure what's going to come out.
Sir, how is it better than AWS? Like everything it is in beta now. Like.
Frankly, I don't know much about the AWS's like ML or DL offerings. To be frank, I haven't used
general, but
I personally believe Google has a lot more data, and that makes them different. That makes their ML algorithms a lot more intelligent. I mean, they have the whole web technically, right? So I'm assuming their intelligence of algorithms is going to be far better than anybody else is just because they have data.
The mark data is actually very, very huge, more than anyone else in the world.
Right.
So,
So your training, makes it more efficient and more accurate, right? And I don't know if that's going to be a differentiator in long term. I don't know, but I'm just saying that's what the case is today.
Sir, could you elaborate on a Google Cloud SQL service? How can a mobile app developer use that service?
I would say, if you go to, let's go to the database sort of thing, right? So it really depends what you want to use, right? If you want to use a document-based store, you should probably use the Google Big Table. But if you want to use a simple SQL, you should use one of the Google Cloud SQL ones or either Spanner ones, based on your demands. Like if you have a huge amount of data and spread across the world, probably Spanner is a better choice. But if it is like you can shard your data into one region at a time, you should probably use normal SQL, right? I can say all of my Indian users' data I only need in India. All of my America users I only need in America region, sort of, right? Then you should probably shard it out. And there is probably like a document-based store that is available as offering, which is like MongoDB kind of data document store, right? So you could use that. I'm sure like much of the mobile app requirements are fluid in the sense they might change over a period of time. Meaning you need a flexible schema. Of course there will be schema. There is never the case of no schema, but you want to evolve the schema over a period of time, which is a little more cumbersome in SQL as compared to like document-based store, right? And yeah, I didn't talk about the IoT core service because again it is in beta. I looked at it today, and I'm trying to get into their IoT group channel through GD channel, whatever. But I haven't got access to it yet because I'm personally curious about the IoT offering of Google in general. But you should definitely. I don't know what your project looks like, but recently we built a small proof of concept where we talk to Alexa. Alexa talks to Raspberry Pi over internet using Ngrok. And then Raspberry Pi talks to a toy called Oli. I don't know if you used a toy called Oli. It's like a Star Wars toy. So we are presenting that at the GopherCon the 10th of March. So we're presenting that as a talk, how to use Golang for all this like robotic automation kind of thing. All right, if no more questions, thank you for your time and thank you for listening to me patiently.
Thank you.
thank you.
Thanks.